Determine the VI characteristics of semiconductor diode.
Hello everyone. Today we'll be looking into the process of electrician practical session to determine the voltage current characteristics of a semiconductor diode.
Objectives: at the end of this exercise you shall be able to refer data book and identify the diode is germanium or silicon, etc. Verify operating voltage and current rating. List the application of the diode. Identify the terminals of a diode and test the diode for its condition. Plot the forward characteristics. Determine the forward resistance of the diode and the barrier potential. Plot the reverse characteristics of the diode and determine the minority carrier current. Tools: instruments. Multimeter, digital, 1 number. Voltmeter, moving coil 0 to 1 volt, 1 number. Milliammeter, moving coil 0 to 25 milliampere, 1 number. Voltmeter, moving coil 0 to 30 volt, 1 number. Microammeter, 0 to 100 microamperes. Semiconductor diode data book, 1 number. Equipment: DC regulated power supply 0 to 30 volt, 1 ampere, 1 number. Materials: assorted types of diodes, 1 N4001 or 1 N4007. 570 ohms, 5 watt potentiometer, 1 number. SPST switch 6 ampere to 50 volt, 1 number. Breadboard, 1 number. Suitable connecting wires for breadboard. Patch cords with clips, 2 sets. 100 ohms a quarter watt resistor, 1 number. 10 ohms a quarter watt resistor, 1 number. Task 1. Refer the diode with data book. Select any one of the given assorted diodes. Record the type number printed on the diode in the table 1. Refer diode data book and search for the type number of the selected diode. In data book, check for the column which indicates material against the referred diode. Record the type of semiconductor used following the tips given below. Under the column material, if code S or Si, silicon. If code G or Ge, germanium. If code Se, selenium. Look in the data book for the column which indicates rated peak reverse voltage, abbreviated as VRB, reverse voltage, and PIV, B, peak inverse voltage. Find and record the indicated value of rated peak reverse voltage in table 1. Get as done in step 4 and record the following specifications of the referred diode from the data book. I, F, maximum average forward current. V, F, forward voltage drop at specified I, F. I, S, maximum forward surge current. I, V, T, maximum reverse current at V, R. Function: normal use by application of the diode. The coding used for function differs from data book to data book. Consult instructor in case of difficulty. Repeat steps 1 to 5 for at least 10 different types of given diodes. Refer diode data book or diode equivalents data book and identify 1 or 2 equivalent diode types for each diode. For those diodes you collected the specification. Get your work checked by your instructor. Task 2. Identify the terminal leads of a given diode. Set the multimeter in ohms range. Connect its leads to a MC voltmeter 0 to 3 volts to find out the polarity of multimeter output voltage. In digital multimeter, the marked polarity and polarity of output voltage are the same. Check the deflection of the voltmeter. If it indicates the voltage, mark the terminal of the multimeter corresponding to the voltmeter polarity. Mark the terminal of the multimeter opposite to voltmeter polarity. If the voltmeter kicks back, then connect the positive marked terminal for the multimeter to one terminal of the diode and other to the negative and observe the reading. A. If the meter reads low resistance, then the lead of the diode connected to positive marked terminal of the meter is the anode and the other is cathode. If the meter does not deflect, then the lead of the diode connected to positive marked terminal for the multimeter is the cathode and the other is anode. If the meter reads low resistance for both polarities, the diode is short. If the meter reads high resistance for both polarities, the diode is open. Task 3. Determine the forward VI characteristic of the diode. Construct the circuit in the breadboard. Set initially bias voltage equal to 0 and switch on the power supply. Set bias voltage equal to 5 volts. Set the potentiometer to minimum position. Close the switch S and adjust potentiometer to increase the voltage across the diode in steps of 0.1 V as per the table. Record the corresponding values of current read by the ammeter in the table. Check the value of voltage across the diode at which the current starts increasing and remain constant at later. Switch off the supply. Plot the graph with forward voltage on x-axis and forward current on y-axis. Determine the forward resistance. R F equal to V F by I F ohms. From the graph, determine the knee point voltage at which large quantity of current starts flowing. Enter the value below. Knee point voltage is equal to 0.7 volts. If the knee point voltage is around 0.3 volt or 0.7 volt, the diode is germanium or silicon respectively. Note: increase the voltage beyond 2 volts as indicated in case diode is not reached in saturation current. Task 4. Determine the reverse VI characteristic of a diode. Construct the circuit in a breadboard. Reverse the diode terminals with respect to previous task. Switch on the power supply and close the switch S. Increase the voltage gradually across the diode by operating the power supply as per table 2 and note down the corresponding current read by the ammeter in table 2. Switch off the power supply. Plot the graph on the same graph sheet, task 3, with reverse voltage on x-axis, or reverse current on y-axis. Minority carrier current equal to 10 microamperes. If the reverse voltage becomes equal to the peak inverse voltage of the diode, then the diode starts conducting and not to increase the voltage beyond peak inverse voltage of the diode. Repeat the experiment for different type of diodes.
Now you have learned to refer data book and identify the diode is germanium, silicon, etc. Verify the operating voltage and current rating. List the application of the diode. Identify the terminals of a diode and test the diode for its condition. Plot the forward characteristics. Determine the forward resistance of the diode and the barrier potential. Plot the reverse characteristics of the diode and determine the minority carrier current. Hope you had a clear understanding on this technical process. Thank you.